You are listening to The Vocal Technologist. Spoken Tech for your ears.
You know, usually we don't talk about building software or managing data. There's this expectation of brute force reliability, like construction, right?
Right, yeah, like pouring concrete.
Exactly. You pour the concrete, it sets, and you just build the next floor. You want a faster query, you buy a bigger server. You want a smarter system, well, you just dump more data into it.
But then, you look at what's actually happening in the trenches of data engineering right now, and suddenly that concrete is, well, it's shifting underneath us. We really can't just throw money and compute at our problems anymore.
We really can't, and that's exactly why we're here. Today's deep dive is about cutting through the absolute avalanche of noise from this massive stack of late June and early July 2026 data engineering and AI updates.
And it is a massive stack.
Oh, it's a mountain. We have so many sources to get through for you today. We're spanning everything from Google dropping zero-shot tabular models to the really gritty realities of corrupted SQLite databases. Our mission today is to figure out how we make data and AI actually work in your real-world production environments without losing our minds.
Or, frankly, losing our budgets, which is happening a lot right now.
Right. So true.
The unifying theme running through all these sources you mentioned is a distinct shift away from that brute force mentality.
Yeah.
We're moving toward highly efficient, context-aware systems.
Yeah.
The industry is collectively realizing that, bigger isn't always better. The systems that actually survive in production for you, they're the ones that are smarter and just highly disciplined.
Okay, let's unpack this, because I feel like there is no better place to see this shift than with AI coding agents, right? We have definitely moved past the blind hype phase here.
Oh, absolutely. The honeymoon is over.
Yeah, it sounds like we've stopped treating AI like some, I don't know, magical oracle and started treating it like a junior developer.
That's exactly it.
It needs heavily optimized documentation and really strict supervision, because otherwise it just confidently breaks things and bills you for the privilege.
Yeah, just look at what Expedia is doing to manage that exact problem. For years, data engineers have spent hours manually parsing these complex physical plans and directed acyclic graphs.
Oh, those sprawling execution DAGs, just awful.
Right, trying to debug long-running Spark SQL jobs. But now, Expedia is feeding those raw execution plans directly into LLMs, along with all the relevant system context.
Wait, I need to stop you there, because I've stared at those Spark execution DAGs. They are a nightmare of nested logic and, highly specific physical operations.
They really are.
So if you feed that into a language model, how is the AI not just, hallucinating terrible optimization advice?
Because they aren't relying on raw LLM guessing anymore. To make this work, you really have to constrain the model. Meta's internal tool, Damonte, is actually a masterclass in this.
Oh, yeah, Damonte.
Yeah, they built an LLM-powered assistant for their data engineers to write SQL and pipelines at a massive scale. But it doesn't just guess based on its training data.
So what does it do instead?
It relies heavily on retrieval augmented generation RAG over Meta's internal data catalogs. It uses multi-step reasoning chains and, crucially, human-in-the-loop feedback. It's a disciplined retrieval system first and a text generator second.
Wow. And, if you are currently staring at a massive cloud bill because your team is letting AI run wild, this discipline is vital.
It's the only way.
Because we are seeing a major shift from subscription billing to per token billing across the entire industry. Elastic just released a really fascinating warning against what they call token maxing.
Right, token maxing. It's such a dangerous trap where teams optimize their AI agents for visible activity, like how many steps an agent takes or how many API calls it makes.
Rather than actual business outcomes.
Exactly. The incentive structure is totally backward. There's an incredible new analysis of 12 terabytes of AI coding agent logs that proves this.
12 terabytes, that's a lot of agent logs.
It's huge. And the data clearly shows that better workflows actually rely on smaller, cleaner context windows, careful upfront planning, and right-sized agent sessions.
So if per token billing is just draining budgets everywhere, how do we actually put guardrails on this? It feels like giving a junior dev a corporate card and telling them to just go figure it out.
Wix actually tested this exact scenario. They ran 250 AI agent evaluations to see what makes an agent perform a task better.
Okay, what were the options?
Well, giving the agent an open-ended set of raw skills to execute or giving it highly optimized, very specific documentation.
Yeah.
The agent-optimized docs improved CLI task completion from 67% to a massive 87%.
Wait, really? Why does simply reading a document beat giving the agent the raw skill to execute the code? That feels counterintuitive.
Well, because open-ended skills require the agent to guess, test, fail, and retry. It just eats up tokens searching for the right path.
Ah, I see.
Highly optimized documentation acts as a constraint. It narrows the search space immediately. So by doing that, Wix didn't just boost their success rate, they actually cut their token usage by 35%.
That is wild. And we're even seeing this constraint-based discipline in how AI evaluates itself, too.
Yeah, exactly.
Like Dropbox is using a framework called DSPy for LLM as judge evaluations to improve their Dash chat responses.
Oh, that's a great example.
They're setting up these statistical validations offline to judge the quality of answers. That keeps token use from ballooning while maintaining accuracy.
And we're also seeing agents start to manage themselves as a coordinated team, which is wild.
Yeah, the Gemma interactions view, right.
Exactly. It's a project where a coding agent challenge organically evolved into a collaborative lab. The agents started sharing playbooks, pooling their API quotas, and even debugging each other's work to, stack small improvements into big gains.
It's like hiring a team of interns, realizing they talk too much and rack up a massive bill, so you give them an ultra-strict operations manual and make them grade each other's work.
That's a perfect way to look at it.
But let's be real for a second. Even with a perfectly optimized, budget-conscious team of AI agents, if I hand them my company's raw database, they are still going to fail spectacularly.
Oh, 100%.
Because the AI has no idea that my company's definition of revenue in Q3 intentionally excludes European subsidiaries,
And that fundamental lack of context is driving the sudden resurgence of ontologies.
Yes, ontologies. They're back.
They really are. For a while, the industry thought we could just rely on basic relational schemas and, let the AI figure out the rest. But an AI agent needs explicit business meaning.
Right.
It needs shared concepts, typed relationships, and limited inference boundaries.
So an ontology essentially encodes the business logic into the data layer itself, rather than leaving it in a dashboard or just in some human's head.
Precisely. High-value AI deployments require those human-curated semantics. Without that grounding, you get catastrophic blind spots.
Catastrophic is right.
PredictHQ just published a staggering metric on this. Even the best, most advanced AI models miss about 60% of demand variability.
Wait, 60%? How can a state-of-the-art model be that blind?
Because the models are mathematically brilliant, but they live in a vacuum. A model doesn't know that, say, a local marathon is shutting down streets on Tuesday, or that a hurricane is approaching the coast.
Oh, sure. Context.
Right. Companies like Uber and Domino's are solving this by actively grounding their AI in real-world event and demand data. The intelligence of the AI is entirely bottlenecked by the real-world context you feed it.
Okay, so here's where it gets really interesting. For decades, we've been told by data scientists that tabular data, the rows and columns that run literally every business, requires bespoke, painstaking feature engineering.
Oh yeah, months of work.
Right. You have to clean it, tune it, and train a specific model for every single data set. But now, Google just dropped TabFM, a zero-shot foundation model specifically for tabular data.
It's a huge deal.
If TabFM is doing this zero-shot, doesn't this threaten to completely flip the traditional data science workflow on its head?
What's fascinating here is the mechanism behind TabFM. It doesn't rely on structural training where you adjust internal weights for a specific data set.
Okay.
It reframes tabular prediction entirely as in-context learning. Google trained this model on 100 million synthetic data sets generated by structural causal models.
Wow. 100 million.
So when you hand it your data, it uses the prompt context to understand the pattern on the fly.
Wait, so no hyperparameter tuning at all? No per dataset training?
None. It benchmarks across 51 different datasets, ranging from 700 all the way to 150,000 rows. TabFM outperformed heavily tuned tree-based baselines.
That is incredible.
Replaces the average-fizzing process of building custom models with simply providing robust context to a general model.
Well, if our models are getting this smart and they're processing complex tabular data instantly on the fly, our underlying query engines and databases have to be lightning fast to keep up.
They have to be.
We can't have a genius AI waiting 10 minutes for a SQL query to return.
No, which brings us to the ruthless engine optimization happening right now. Engineering teams are tearing out infrastructure just to shave off milliseconds.
Literally milliseconds.
Yeah. Arcesium spent 18 months migrating thousands of SQL queries from Athena to Trino and finally to DuckDB.
Okay, I imagine Athena hit AWS account and service limits at scale, but why move off Trino? Trino is built for massive distributed queries.
Well, Trino solved the scalability problem, but the compute costs for their specific workload profile became just unjustifiable.
Budget again.
Exactly. So they migrated their small to medium analytical workloads to DuckDB. The result was a 50% cut in both query costs and runtime, alongside a 40% lower memory footprint.
50% cut. But DuckDB runs in process, right? So
Right.
it avoids a lot of the network overhead of a distributed system like Trino.
Right.
But migrating thousands of queries isn't just flipping a switch.
Oh, not at all. They had to navigate serious engineering hurdles. They had to figure out glueless schema evolution, handle complex JSON fallbacks when data types mismatched between systems.
Right, mismatches.
Yeah, and deep tune their thread parallelism to get that 50% cost reduction.
Well, and while DuckDB is reshaping analytics, Sedona DB 0.4 is doing something genuinely mind-blowing with spatial joins.
Oh, the RayBooster update.
Yes. They introduced a GPU spatial join engine called RayBooster. It uses NVIDIA ray tracing cores to accelerate geometry intersection queries. It's up to 5.9 times faster.
It's so fast.
In some benchmarks, a consumer RTX 3090 graphics card is beating a massive enterprise-grade H100 chip on these spatial workloads.
Yeah.
It's like finding out a souped-up street Honda Civic just smoked a Formula One car in a highly specific race. Why are ray tracing cores, which are built for video games, so good at spatial data joins?
It comes down to the underlying mathematics of the hardware. In a video game, ray tracing involved calculating the exact moment a line of light intersects with a 3D polygon to render a shadow, right?
Right.
Well, that exact same mathematical operation is used in spatial data to figure out if two geographic boundaries, like, say, a delivery zone and a zip code overlap or intersect.
Oh, that makes so much sense.
Yeah, so Sedona DB bypasses the standard compute cores and offloads that specific math directly to the ray tracing cores.
They hijacked the hardware shortcut. That is brilliant.
It really is.
And this obsession with speed is everywhere. Manticore Search rewrote its entire embedding pipeline on the ONNX runtime and saw a 14x throughput lift for low-latency vector search.
Yeah, the key to Manticore speedup was disabling intra-op spinning. Usually threads will constantly spin, checking for new operations to execute.
Which causes massive lock contention, right?
Exactly, especially when processing many small documents.
Yeah.
By disabling that spinning and processing documents individually, they eliminated the bottleneck entirely.
Amazing. And then you have Hardwood 1.0 building a JVM native Parquet reader hitting 16.5 million rows per second with massive pushdown speedup.
Unbelievable numbers.
And let's look at SmithDB. They built an inverted index for full-text search and boosted their construction speed by 2.2 times using something called string interning.
String interning is a really fascinating memory shortcut. In a standard database, if the word active pops up in a million different user profiles, the system basically brainlessly creates a new memory allocation for that string a million times.
Which is terribly inefficient.
Right. String interning stores the word once in a central pool and just points to that single memory address every time the word appears.
It drastically reduces the memory footprint, allowing them to merge local SSD indexes with object storage segments to achieve, like, sub-second data freshness.
Yes.
But if we connect this to the bigger picture, all this raw speed from string interning and ray tracing is completely irrelevant if your data architecture shatters the moment a schema changes or a massive data update hits.
If we connect this to the bigger picture, raw speed is irrelevant if your system is brittle. That's the ultimate bottleneck, the moving target problem.
Right.
You can have the fastest query engine in the world, but if your data lake can't handle a continuous stream of updates, you're in trouble. Apache Hudi just published a deep dive on this exact challenge. How do you build reliable indexes on a continuously updating data lake?
Because you have to balance index freshness with the immense overhead of constantly writing to it.
Exactly.
And if the schema changes midstream, everything downstream breaks. Pinterest had to completely revamp their database ingestion framework for change data capture across Kafka, Flink, Spark, and Iceberg.
And they solved it by treating the schema as a strict contract. Any schema changes now require pull request auditability, SLA-based recovery, and backfill fallbacks.
So if a column changes, the system actually prevents downstream drift from corrupting the analytics.
Yep. Razorpay faced a similar beast, too. They had to turn scattered transaction data across over 500 million user profiles into real-time queryable audience segments.
500 million, wow.
Yeah, they used Airflow DAGs and Spark for daily computation, but they layered in temporal workflows to orchestrate reliable DynamoDB ingestion with zero downtime versioning.
And we are also seeing the underlying platforms evolve to handle this natively, like Apache Flink 2.3.ver is moving aggressively toward declarative streaming.
Which is huge.
Right. This allows materialized tables to evolve through simple DDL changes without forcing engineers to manually reprocess years of historical data.
Thank goodness.
Yeah. And TDB is doing something similar by offering open source, scalable, hybrid transactional and analytical processing.
Right.
And for anyone who needs raw data to test these systems without starting from zero, Common Crawl just released over 6 billion edge web graphs specifically for link analysis.
6 billion.
So what does this all mean for you listening right now? If you're building a data lake today, are we finally at a point where the infrastructure handles the moving target of data updates automatically, or are you still required to duct tape these systems together?
Well, you aren't duct taping systems together anymore, but you are still the chief architect.
Fair point.
Tools like Flink's declarative streaming or Iceberg's table formats provide incredible building blocks, but they do not design the house for you. You have to ensure the foundation can shift without cracking. Which brings us to the most unpredictable component in all of this.
The human element.
Yes.
We can deploy zero-shot tabular models and ray tracing GPUs all day, but all this incredible technology still requires human governance. And when humans fail, the systems fail.
Always.
There was a fantastic piece from our sources pointing out that data quality failures are almost always ownership failures.
When multiple teams consume the same metric, but no single person controls its mathematical definition, trust completely erodes. The fix isn't a new observability tool. The fix is explicit metric governance. You need one named owner who holds the decision rights for that metric.
That makes a lot of sense. The sources highlight a similar misconception with data residency, actually. People always treat data residency as a legal problem, or a compliance headache that just the lawyers handle.
Oh, totally.
But it is actually an infrastructure design problem. If you have regulated workloads across different countries, you need reproducible CI/CD pipelines and region-aware platforms to handle the inevitable feature gaps between managed services in different regions.
And Snowflake actually released a stark warning about evaluating infrastructure that ties directly into this reality.
Oh, what did they say?
They argue that real workload performance is the only metric that actually matters. Flashy headline benchmarks run on isolated perfect data sets mean absolutely nothing.
Nothing at all.
You have to test for real data scale, concurrency, latency, and cost under your specific messy organizational conditions.
Because things break in the real world.
Exactly.
If you want to avoid babysitting your pipelines, you can build a self-hosted dbt cloud using Prefect and FastAPI.
Wow.
But crucially, you have to use APIs, not brittle CLI scraping, for reliable job management.
Right. Definitely use APIs.
Meanwhile, dbt Labs is pushing wizard use cases for dbt Fusion to automate pipeline management. But, no matter how much you automate, you still have to watch out for foundational database pitfalls.
Because foundational mechanics always apply. PostgreSQL warns that simply having too many small tables bloats your internal catalogs and completely ruins the query planner's efficiency.
Oh, that's a good one. And if you are using Kafka share groups, you can suffer from pathological fetch weights if you use the record limit setting with fewer consumers than partitions under a skewed workload.
Oh, I've seen that.
Yeah, one consumer gets stuck waiting for a limit on an empty partition while another partition completely overflows.
And even SQLite, which is famously robust and embedded in almost everything, reminds us that it can still be entirely corrupted by unsafe file access, missing rollback journals, or risky Presumus settings.
This raises an important question. We build these infinitely complex systems with AI agents debugging Spark execution plans and GPUs performing spatial math at light speed. Yet, the root cause of a broken executive dashboard is usually just that two teams couldn't agree on the definition of revenue.
This raises an important question, doesn't it?
Yeah.
We have all this power, or, an engineer just left a file lock open on a SQLite database. The complexity of the technology is scaling exponentially. But the foundational principles of engineering discipline remain completely static.
So to synthesize everything we've covered in this deep dive, we are officially entering an era where AI agents are collaboratively debugging our code to save on token costs. Foundation models are processing complex tabular data on the fly without manual feature engineering. And consumer GPUs are parsing spatial data at blistering speeds.
It's an incredible time.
It really is.
Yeah.
Yet despite all this raw technological horsepower, success still relies on the decidedly unglamorous work. You still need strict semantic ontologies, you still need to name clear human owners for your business metrics, and you absolutely must respect the mechanical limits of your databases.
If AI agents are now collaboratively debugging each other's code,
Uh,
and systems like Flink and TabFM are automating away the tedious schema processing and feature engineering, what does the daily life of a human data engineer look like 5 years from now?
hmm.
Will you still be building the pipelines, or will you just be acting as a diplomat, negotiating the business logic between a hyper-efficient AI and your CEO?
Wow. That is a fascinating question to leave on. Thank you so much for taking this deep dive with us today. Keep learning, keep questioning, and we will catch you next time.
Spoken Tech for your ears.